In this video, we discuss learning outcome number 6, which is the difference between sampling errors and non-sampling errors. So sampling errors are actually probably exactly what you would expect. These are errors due to sampling. So we have the entire population and we're interested in some quality typically about the entire population. Since we're not surveying everyone, or we don't have data for the entire population, there's going to be some error due to the fact that we're only looking at a sample. So this is our first type of sampling error. It's called random sampling error. This is the discrepancy between the sample result and the true population result. So if you were looking at like poll results, say, for the election, the population might be not every adult of voting age in the United States, but every adult that's planning to vote in the United States. If you were to look at poll results, well, the poll would theoretically consist of people that were planning to vote. So you've got a subset of the population that will actually be voting. But you're not going to get exactly the same result with a subset that you would get with the entire set. You're not going to get the same result with a sample that you would with the true population, even if you just looked at the sample on election day itself. So random sampling error is sampling error that just results from the fact that you're looking at a sample instead of the entire population. So this is just due to chance sample fluctuations. So if you're looking at polling data this year, you'll probably see some Gallup polling data throughout election season on TV, and you'll see how the two front runners are comparing as far as their favorability among likely voters. They're always going to measure, they're always going to talk about some margin of error. And that margin of error is related to this random sampling error. It's going to be wrong. It's not going to be, it's very unlikely that it's going to be exactly the same as the population result if everyone had been polled on the day of the election itself, because we're not interviewing everyone. That's random sampling error. Now, there are also non-random sampling errors, and that just comes from poor sampling, basically. If you have a convenience sample or a voluntary response sample, if you're watching something on TV and they say, call in and tell us your opinion on this, or if you are on the internet and they say, something pops up and says, participate in this poll, we'd love to know how you think. There will be error because we are talking about the sample, or because we are looking at a convenience sample or a voluntary response sample. And that sample is not necessarily representative of the population that we're interested in. There's something about those people who decide to participate in the voluntary response sample that makes them qualitatively different from those who choose not to. And a convenience sample is also non-representative because it's not random, it's not randomly selected, and it's just sort of selected from whoever you can get nearby that will participate. So both of those are sampling errors. We expect this random sampling error. We get a little bit of error just due to the fact that we're looking at the sample and not the entire population. We want to minimize this non-sampling error as much as possible. So we want to try to stay away from convenience samples and stay away from voluntary response samples, and use random sampling as much as possible. Now, it's also possible to have non-sampling error. And we've actually talked a little bit about some of this. This is just due to human error in our design. And sometimes there's human error in data collection or data entry. So we've got wrong data entry on this list, computing errors, maybe you programmed it into Excel incorrectly, or SPSS, you used that program and you did something incorrectly. Maybe the questions that were asked in your survey, were worded in a biased way such that led participants to have a certain, to provide a certain result that may not be representative if that question had been worded in more of an unbiased way. Maybe you've got false data provided by respondents. Sometimes people will lie just to make themselves look better. But most of the time, we're not thinking about people lying. Sometimes it's just people are mistaken, and they, you know, if they're reporting their weight or something like that, their estimate of their weight may be different from their actual weight. Self-report data can be questionable. Now, if you've got all of that, or if you have an excellent study, it's very well designed, you've taken everything into consideration, but then when you look at the data at the very end, you see sort of what you expect to see and you're forming a biased conclusion, that's a non-sampling error. And then of course, if you apply statistical methods that are not appropriate for the circumstances. So we talked about earlier all of those different, what were they called? Levels of measurement. And when you're working with data at a nominal level of measurement, there are certain things you should not do that you can do with data at an interval level of measurement. And there are certain things you shouldn't do with data at an interval level of measurement that you would do with data at a ratio level of measurement. So we want to make sure that we're using statistical methods that are appropriate for the circumstances. If we don't, that would introduce some non-sampling error. So we want to minimize error as much as possible, which means minimizing all of the error like this, and then minimizing that sampling error that we talked about over here that comes from using a convenience sample or a voluntary response sample, or otherwise choosing a sample in such a way that that sample may not be representative of the entire population. Now, because we're sampling, we're still going to have some error. That's that random sampling error. And we completely expect that. And no one's going to give you a hard time if your sample does not give you exactly the same result as the entire population. So let's say you were to do a poll for the president and you were to get some statistic, you know, 52% of people favor this person. That's not necessarily the percentage of people that are voting in the country that would favor the person at that time. There's going to be some error there because it's based on a subset of the entire population that may vote or that would vote on that day, but not necessarily based on, well, it doesn't give us data for everyone. If it gave us data for everyone, then it wouldn't be a sample, and it would be accurate. So expect some random sampling error, but we want to minimize those other types of sampling errors, non-random sampling errors and non-sampling errors like those on this list.